Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. So in today's video, we will be looking how to find what is tan inverse of x plus tan inverse of y based on the values of x and y. Similarly, what is tan inverse of x minus tan inverse of y based on the values of x and y. Okay, as a part of theorems. So already we have discussed many properties of inverse trigonometry in the previous videos. So go and check it. Those are our basics. Those are very important. Now today we'll look at these two properties. See, this formula is correct if x is greater than 0 and y is greater than 0. Keep this in mind. And again we will see what is the formula if x is less than 0 and y is less than 0. So first of all, if x and y both are positive, then tan inverse x plus tan inverse y has three possible formulae. Case 1, if x into y is less than 1, if x into y is less than 1, then tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. And case 2, if x into y is greater than 1, then this is equal to pi plus tan inverse of x plus y by 1 minus xy. And case 3, if x into y is equal to 1, then this is equal to pi by 2. So it all depends on the value of x into y. So first of all, x and y both should be positive, and after that there are three cases depending on the value of xy. Okay now, so let us see how to prove this. See, x is positive and y is positive. We are talking about the proof. Let tan inverse x is alpha and tan inverse y is beta. Okay now, so here tan inverse x is alpha and tan inverse y is beta, and already x is positive, so x is in the domain of tan inverse function, so tan inverse will go to the right side. That implies x is equal to tan alpha and here y is equal to tan beta. And observe one thing, since x is positive, alpha is in first quadrant between 0 and 90 degrees. And if x is negative, then alpha is in the fourth quadrant between minus 90 and 0. It all depends on the range of tan inverse x. Keep this in mind. Since x is positive, alpha is between 0 and 90 degrees, and even beta is also between 0 and 90 degrees as y is positive. Okay na? See, I wrote alpha between 0 and 90 and beta between 0 and 90. So we are going to prove the formula of tan inverse x plus tan inverse y. That means alpha plus beta. Correct or not? So let me add this. Alpha plus beta is between, while adding, we will add directly 0 plus 0, minimum plus minimum and maximum plus maximum while adding the inequalities. So alpha plus beta is between 0 and 180 degrees. Alpha plus beta is between 0 and 180 degrees. Keep this in mind. Now we are supposed to find the formula of tan inverse x plus tan inverse y. That means alpha plus beta. So for this purpose, let me take tan of alpha plus beta. Tan of alpha plus beta is equal to what? Tan alpha plus tan beta by 1 minus tan alpha tan beta, which means tan alpha is x, tan alpha is x plus tan beta is y. So x plus y by 1 minus x into y. This is tan of alpha plus beta. Keep this in mind. If alpha plus beta is in the restricted domain of tan function, if it is in the restricted domain of tan function, then tan will go to the right side, tan inverse. But what is alpha plus beta here? It is between 0 and 180 degrees. But the restricted domain of tan function is between minus 90 and plus 90. The restricted domain is between minus 90 and plus 90. So now I cannot transfer tan to the right side. Remember this. From here we will have three cases. Okay now. So remember this. Tan of alpha plus beta is equal to this. Okay now. From here we have three cases. Case 1. What if x into y is less than 1? What happens if x into y is less than 1? Take xy to the right side, 0 less than 1 minus xy. Or we can also say that 1 minus xy is positive. 1 minus xy is positive. Since x is positive and y is positive, since x is positive and y is positive, x plus y is also positive. Okay na? So understand that x plus y is positive, 1 minus xy is also positive. Therefore, x plus y by 1 minus xy. The numerator is positive, the denominator is positive. Therefore, x plus y by 1 minus xy is also positive. So this is what? Tan of alpha plus beta according to the previous equation number 1. So tan of alpha plus beta is positive. Alpha plus beta is between 0 and 180 degrees. That means in first quadrant and second quadrant. Since tan of alpha plus beta is positive, I should take alpha plus beta in first quadrant. If tan of alpha plus beta is negative, I will take alpha plus beta in second quadrant. But here it is in first quadrant. Now come back to this. Tan of alpha plus beta is equal to x plus y by 1 minus xy from first equation. Alpha plus beta is between 0 and 90 degrees. Alpha plus beta is between 0 and 90 degrees. This is in the restricted domain of tan function. What is the restricted domain of tan function? The restricted domain of tan function is between minus 90 and plus 90. Correct or not? So alpha plus beta is in the restricted domain of tan function. Therefore, tan will go to the right side. That means what? Alpha plus beta is equal to tan inverse of x plus y by 1 minus xy. And what is alpha plus beta? Alpha means tan inverse x according to the introduction, and beta means tan inverse y. It is equal to tan inverse of x plus y by 1 minus xy. So this is the decision making step. You got it? So in case 1, when xy is less than 1, we got tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Let us go to case 2, when xy is greater than 1. So we are in case 2 where x into y is greater than 1. Okay na? Xy is greater than 1. Therefore, 0 is greater than 1 minus xy, or 1 minus xy is less than 0. 1 minus xy is less than 0. We already have x is positive and y is positive. That means x plus y is also positive. So x plus y is positive and 1 minus xy is negative. 1 minus xy is negative. So therefore, what is x plus y by 1 minus xy? X plus y by 1 minus xy. Positive by negative will be negative. Which means this is what, according to equation 1, this is tan of alpha plus beta. Now tan of alpha plus beta is negative, where alpha plus beta is between 0 and 180 degrees. If tan of alpha plus beta is positive, I have taken alpha plus beta in the first quadrant. Now tan of alpha plus beta is negative, so I will take it in the second quadrant. That means what? That implies alpha plus beta is between pi by 2 and pi in the second quadrant. Now alpha plus beta being in second quadrant is not in the restricted domain of tan function. What is the restricted domain of tan function? Between minus pi by 2 and plus pi by 2. Correct or not? So this is not between minus 90 and plus 90. So what are we supposed to do? Now this step is very, very important. I have explained this in my previous proofs already. So the first quadrant angle is taken as theta. The second quadrant angle is taken as pi minus theta. The third quadrant angle is taken as theta minus pi. If theta minus pi doesn't work, you can try with pi plus theta. Okay, now keep this in mind. But generally I will take theta minus pi. And fourth quadrant angle is minus theta. Okay, now so tan theta is equal to, tan is positive in first quadrant and third quadrant, correct or not? So tan theta is equal to tan of theta minus pi. Tan of theta minus pi. So for this purpose, since alpha plus beta is not in the restricted domain of tan function, check with alpha plus beta minus pi. That means theta minus pi. Theta minus pi, where theta is alpha plus beta. Where theta is alpha plus beta. Alpha plus beta is not in restricted domain of tan function. Check with alpha plus beta minus pi. So if I take alpha plus beta minus pi, that means I have subtracted pi. So pi by 2 minus pi is minus pi by 2. Pi minus pi is 0. And this is now in the restricted domain, of tan function between minus 90 and 0 degrees. So that is why. Okay, now what I'm going to do. Now let us get back to the first equation. Tan of alpha plus beta is equal to x plus y by 1 minus xy. If this is theta, we know that tan theta is equal to tan of theta minus phi. So that means tan of alpha plus beta can be written as tan of alpha plus beta minus phi. Okay, na? So therefore tan of alpha plus beta is written as tan of alpha plus beta minus pi. Now this is in the restricted domain of tan function. Correct? That is the reason why tan will go to the right side as tan inverse. So therefore alpha plus beta minus pi is equal to tan inverse of x plus y by 1 minus xy. And take minus pi to the right side. So what do we get? Alpha plus beta is equal to pi plus tan inverse of x plus y by 1 minus xy. And what is alpha? Alpha is tan inverse x. Alpha is tan inverse x. Plus what is beta? Tan inverse y. Beta is tan inverse y. So therefore alpha is tan inverse x plus beta is tan inverse y is equal to pi plus tan inverse of x plus y by 1 minus xy is equal to. So if therefore what is the conclusion? If xy is greater than 1, then tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y by 1 minus xy. And what is case 3? Case 3 is when x into y is equal to 1, right? So if x into y is equal to 1 in case 3, we get y is equal to 1 by x. We get y is equal to 1 by x. And we are supposed to find tan inverse x plus tan inverse y. That means tan inverse x plus tan inverse of, what is y here? Y means 1 by x. And in the previous properties we have seen that tan inverse of 1 by x is nothing but cot inverse x. Tan inverse of 1 by x is same as cot inverse x, where x is not equal to 0. Okay, fine. And tan inverse x plus cot inverse x, in the previous properties we have seen that it is equal to pi by 2. Therefore, if xy is equal to 1, then tan inverse x plus tan inverse y is equal to pi by 2. So we will see so let us conclude this theorem. What is it? So the conclusion says this theorem is applicable only when x and y both are positive. Okay, na? So therefore if x is positive and y is positive, then we can say that tan inverse x plus tan inverse y has 3 possibilities. If xy is less than 1, then tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. And if xy is greater than 1, it is equal to pi plus tan inverse of x plus y by 1 minus xy. And if xy is equal to 1, then it is pi by 2. If you want to remember it, whether it is pi plus or pi minus or minus pi plus, how will we remember it? Very simple. Theta first quadrant, pi plus theta third quadrant. Tan is positive in first quadrant and third quadrant. So theta pi plus theta. Like that we can remember. Okay, na? So now we will see the next theorem where x is negative and y is negative. What happens if x is negative and y is negative? So before going to that theorem, a small application. Let us find tan inverse 3 plus tan inverse 1 by 2. What is tan inverse 3 plus tan inverse 1 by 2? So first of all, x is equal to 3, which is positive. y is equal to 1 by 2, that is also positive. X is positive and y is positive. So we can use this theorem. Next, what is x into y? What is x into y? X into y is 3 into 1 by 2, that is 3 by 2. 3 by 2 is greater than 1. That means what? Xy is greater than 1. So therefore, what is tan inverse x plus tan inverse y formula? If xy is greater than 1, it is pi plus tan inverse of x plus y by 1 minus xy. That means what? Therefore, tan inverse 3 plus tan inverse 1 by 2 is equal to pi plus tan inverse of 3 plus 2 by 1 minus 3, what is it? 3 plus 1 by 2. X is 3 and y is 1 by 2 by 1 minus xy, 3 into 1 by 2. So simplify it, what do we get? Pi plus tan inverse of, the numerator is 7 by 2, the denominator is minus 1 by 2. We will get minus 7. So pi plus tan inverse of minus 7, or it is same as pi, and tan inverse of minus x is minus tan inverse x now. So the answer is pi minus tan inverse 7. The answer is pi minus tan inverse 7. So therefore, tan inverse 3 plus tan inverse 1 by 3 is equal to pi minus tan inverse 7. So now we will go for the next theorem. What if x is negative and y is negative? So if x is negative and y is negative, then tan inverse of x plus tan inverse of y again has three different formulae. If xy is less than 1, same, tan inverse of x plus y by 1 minus xy. If xy is greater than 1, what we have got? Minus pi plus tan inverse of x plus y by 1 minus xy. And if xy is equal to 1, then tan inverse x plus tan inverse y is minus pi by 2. Three different answers. You can prove this theorem using the method that I have explained before, but I will prove it little differently. Using the previous theorem, I will prove this theorem. Using previous theorem, I will prove this theorem. So let us see how to prove. Okay, x is negative and y is negative na. So let x is equal to minus capital X. Let x is equal to minus capital X. See, x is negative, then minus x is positive. Then x is negative means minus x is negative. Therefore, x is positive. And similarly, I will take y is equal to minus of capital Y. Since y is negative, minus y is also negative. Therefore, y is positive. Therefore, y is positive. And what about what if xy is less than 1? Or what if xy is less than 1? X into y means small x into small y means small x is minus capital X and small y means minus capital Y, less than 1. Minus into minus plus. So capital XY is less than 1. So therefore, dear students, if xy is less than 1, then capital X into capital Y is also less than 1. So what is it? So we can conclude that if x into y is less than 1, then capital X into capital Y is also less than 1. Similarly, if xy is greater than 1, then capital X into capital Y is also greater than 1. And xy is equal to 1 means capital X into capital Y is also equal to 1. So x into y is same as capital X into capital Y. Now what are we going to do? So case 1, if capital X into capital Y is less than 1, then tan inverse x plus tan inverse of y, tan inverse of capital X plus tan inverse of capital Y. Already capital X is positive and capital Y is positive, so we can use the previous theorem, and according to the previous theorem, tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy in terms of capital letters. Now let us replace capital X and capital Y with small x and small y. So what is it? Tan inverse of capital X is minus small x and capital Y is minus small y. Here also let us do the same. Tan inverse of minus x minus y by 1 minus, and I told you that capital X into capital Y is same as small x into small y. Tan inverse of minus x according to the previous properties is minus tan inverse x, and tan inverse of minus y is minus tan inverse y, and here also I can take minus, it is what, tan inverse of minus of x plus y by 1 minus xy, and here also minus will come outside. So multiply with minus on both sides, we will get the result. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. So what is the conclusion, dear students? Therefore, if xy is less than 1, small x into small y is less than 1, then tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. So this is true when both x and y are negative. Same way you can prove the next one. So in case 2, what is it? If xy is greater than 1, capital X into capital Y is greater than 1, then small x into small y is also greater than 1. Correct or not? So now let me take it, and according to this and this, let us use the previous theorem. So when capital X and capital Y both are positive and capital X into capital Y is greater than 1, then tan inverse of capital X plus tan inverse of capital Y is equal to pi plus tan inverse of capital X plus capital Y by 1 minus capital X into capital Y. So replace capital X with minus x and capital Y with minus y. Because capital X into capital Y is same as xy. Okay na? And take and use the previous properties. Tan inverse of minus x is minus tan inverse x, and this is minus tan inverse y. Here pi as it is, taking minus outside. So minus tan inverse of x plus y by 1 minus xy. Then multiplying with minus on both sides. Tan inverse x plus tan inverse y is equal to minus pi plus tan inverse of x plus y by 1 minus xy. So this is true if xy is greater than 1. So if xy is greater than 1, then tan inverse x plus tan inverse y is minus pi plus tan inverse of x plus y by 1 minus xy. Similarly in case 3, if xy is equal to 1, case 3, if xy is equal to 1, capital X into capital Y is equal to 1 means small x into small y is also equal to 1. Okay na? So what is tan inverse x plus tan inverse y according to previous theorem? It is pi by 2 when xy is equal to 1. Replace capital X and capital Y with small x and small y. Tan inverse of minus x plus tan inverse of minus y equal to pi by 2. Using the previous property, tan inverse of minus x is minus tan inverse x, and this is minus tan inverse y, and multiplying with minus on both sides, tan inverse x plus tan inverse y is equal to minus pi by 2, minus pi by 2. So therefore, how can we conclude, dear students? What do we conclude? If x is negative and y is negative, if x is negative and y is negative, then tan inverse x plus tan inverse y has 3 different answers based on x into y value. So xy is less than 1 means, xy is less than 1 means this is equal to tan inverse of x plus y by 1 minus xy, and if xy is greater than 1 means this is equal to minus pi plus tan inverse of x plus y by 1 minus xy, and if xy is equal to 1 means, if xy is equal to 1 means this is equal to minus pi by 2. Two different theorems. The previous theorem was when x and y both are positive, and this theorem is when x and y both are negative. Okay na? So one more theorem is there, tan inverse x minus tan inverse y. We will discuss it in the next video. Thank you. And if you have understood this concept, do like the video and share it to your friends, subscribe the channel if you have not yet subscribed it. So in the next video we will discuss about tan inverse x minus tan inverse y, and at the same time some questions on these models, on these properties. Thank you.